is physics. In this video, I'm going to do a calculation of the density of air. To do that, I'm going to use a syringe, which I put together. This isn't my idea. There are many YouTube videos of a similar idea. So I put this syringe together. At one end of the syringe, I have a ball bearing and a little bit of a tube here, and I glued this part here together with crazy glue. And I have a small screw here as well. So we're going to measure this the way it is with the screw. And I'm getting 27.4674. I'll go with that. The scale is super sensitive. It's down to 4 decimal places. Any movement of air will actually start to impact the scale. So that's our measurement of the syringe. Now it has air in it right now. This part right here has air in it. And I'm going to take a volume at the end of the plunger. You can see here where the plunger is at the very end of the plunger. Find out what this volume is. And I read the shade over 5 milliliters. So we'll go 5.5 milliliters right here. So the volume that I'm starting with is about 5.5 milliliters. I'm going to create a vacuum. I'm going to push out the air that's in this part of the chamber. I'm going to push it out and creating a vacuum on the inside. Now this is hard. It really requires some effort, as you can see. As soon as I let go, atmospheric pressure is pushing on this, pushing it back because there's no air going on this side. So I'm going to need a little help. I'm going to pull this out. And there is a hole there in the centerpiece in order to put that, so that it can hold. Now I've generated a vacuum in here. I pushed all the air out and generated a vacuum in here. Let's see, this ought to measure mass-wise a little bit less than the original, 27.4330. And these are in grams. These are all in grams. And the volume now, same as before, I need to know what the volume here is in this chamber. I'm going to measure from the exact same spot as it was earlier. And I'm measuring 30, looks like 34, probably an even 34 milliliters. 34 milliliters is the volume of the chamber. Milliliters. So I have all the data that I need. Have a calculator? Have my calculator, please. So as I do this, the density of air, density is the equation. Density is equal to mass divided by volume. In order to determine the mass of the air that we had, we're going to take the mass of the syringe plus the screw that we had minus what it was afterwards when we pushed all the air out. And if I subtract those two, that ought to give me the mass of the air. So let's put that in the equation up here. So mass is going to be 27.4674 grams minus 27.4330 grams. That subtraction will give me the mass of the air which I pushed out, divided by the volume. And the volume went to 34 minus 5.5 milliliters. That will be the volume of the vacuum. And I have a helper working on the calculator right now as quickly as he can in order to give me this calculation.
It's 11 point.
0.00.
Yeah, it should be 0.0.
0.00116.
Oh, it's no.
calculation, calculating. You know, when I send out messages on Messenger, we have those three little buttons that goes link to the link to the link to the link.
That's what's
That's what's happening
now.
right now. To the link to the link to the link. There it
Equal?
goes.
Equal. And then 34 minus.
Is equal to. Behind the scenes, there's lots of calculating going on. Maybe we should work on our calculator skills.
Yeah. 0.034 divided by 28.5. So do that on your calculator because you can't do
0.034
brackets on
divided
this.
by 28.5.
Yeah, do that one. Zero point zero zero 11929
1129.
92.
92.
Yeah.
There we go. After all of that, and it's grams per milliliter. This is the density of air. The actual density of air, if you Google it, it would be actual density of air 0.0013 grams per milliliter. We come close, give or take a little bit of error that happens here in our experiment. And with that, this is physics.